Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. This episode is brought to you by AutoRescueTools.com and Isaac Rodell. If you are looking to get into module programming, but you are not sure what kind of laptop you're going to need or how to set it up for programming, Isaac is your guy. He can set up laptops specifically to do control module programming for specific brands with partitioned hard drives and all the software that you're going to need to do this. He also sells key cutting equipment, scan tools, and other diagnostic equipment. I bought some stuff from him in the past, and the support is phenomenal. So I highly recommend checking out the website. Again, that's AutoRescueTools.com. The link will be in the show notes. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you so much for joining me. Just me on the show this week, and I'm going to be talking about blind spot module or sensor calibration today. These are the radar sensors that you're going to see on the rear corners of vehicles. You can also see radar sensors that are effectively going to be the same thing, both on the front corners of some newer vehicles, and you could even group in the forward radar on these or the front radar for adaptive cruise control. But the calibration process is going to be relatively similar, and the function, of course, is relatively similar. It's just what object are we trying to detect as the vehicle's going down the road. But there's a piece about the blind spot module calibration that I really want to touch on, and kind of the point of why I'm making this episode. So I'll give you some general knowledge. A lot of you are already familiar with these systems. They've been used for many years now, and we're seeing them on just about every make and model in one way or another, whether it's just a front radar or just the blind spot. And there's some variation between the makes and models and the calibration processes or lack thereof. But again, with the blind spot module specifically, we were having a little bit of a challenge in order to get these things calibrated correctly. And I want to share the solution that we came up with, or I mean, other people have come up with it too, but the solution that we've implemented, and just also some knowledge about the system and when you're going to do a calibration on these blind spot systems, something, or even just the radars in the front in general, something that you should be aware of before you start setting up targets and hitting buttons. So again, we're going to focus on the blind spot modules, rear corners of the vehicle, and we get called in quite often. It's one of the services that we offer, of course, is doing ADAS calibrations. And so after a vehicle repair, usually involving body or structural repair in one form or another, a lot of the time it's body shops that are going to be calling us for this, but sometimes shops too. It could also be just replacement of the module itself because of damage or corrosion, right? We see that a lot with General Motors vehicles, of course. They're well known to have major corrosion issues in the blind spot modules. And those specifically don't actually require any calibration. They self-calibrate after you go drive the vehicle. And there's not even a dynamic function to activate on most General Motors vehicles. Maybe something like brand new, but at least all the ones that we've worked on so far, you bolt it up, you program it, and it's good to go. And it bolts to the bump. I wouldn't even say it bolts. It slides into a plastic locking mechanism that is glued to the inside of the rear bumper. And so outside of maybe re-gluing that bracket to the inside of the bumper, you're not doing any physical adjustment. You're not doing any calibration, right? So there's not much to talk about there. But anyways, my point of this is we get called in to do the calibrations on the ones that do require a calibration. And in order to do that, we're going to use a couple different tools in order to allow the module or the sensor, right? Sometimes they are I would say a lot of the time, they are their own independent control module, which you can see on the topology of the scan tool. You can talk to that module directly. You can get codes out of it. Sometimes, I should say a lot of the time, the two modules are set up in like a master-slave configuration where maybe you can only talk to the left module, and then the left module actually receives data on a private CAN from the right side or something like that. Sometimes you still have master-slave set up, but you can still talk to them both with the scan tool. There's a lot of different configurations with it. In some cases, they are just a sensor. I don't know. You could still consider it a module, but not a module in the sense that you would talk to it directly with a scan tool. And one that comes to mind on that is like Chrysler Town and Country minivans. The sensors themselves do their thing. They do the radar thing. And then there's a separate module, which is your blind spot module, which takes information from both of those. So I don't know, the terminology gets confusing, but anyways, this is the radar unit that's going to be bolted to the rear corners of the vehicle to detect someone that's in your blind spot, right? And these are actually, impressive sensors, not only that they can measure the distance and the angle and whether there's a vehicle, in your blind spot, but also they have to be able to determine the difference between a stationary object and an object that is actually in your blind spot, like a moving vehicle that is in the lane next to you. And it has to be moving in the right direction, right? Imagine if you're just on a 2-lane road, right, going opposite directions, and a vehicle passes by you going the opposite direction, you don't want the blind spot system to trigger the light because that's not its purpose. That vehicle is moving away from you, so it has to be programmed to catch that, because essentially it's going to see that vehicle is there. The radar electromagnetic waves that it sends out is going to hit that vehicle, but because it's moving away, it's programmed to not trigger the light. Or if you drive by vehicles that are parked on the side of the road, you don't want the light triggered, so it's programmed to observe that. It's only going to be a vehicle that is, moving with you, but in the opposite lane. And they're set up physically in a way so that they can detect a vehicle at a certain spot, right? Your blind spot. Okay, that's the idea. And that's going to change slightly depending on the actual vehicle. And we'll talk more about that angle and how they're positioned in order to do that, depending on the different vehicles. Well, basically, when these things get replaced, or certain components removed, or again, structural damage, and we see this a lot, they have to be calibrated. But there's a second piece to this, and again, this is kind of what I wanted to talk about, is when there's damage to wherever that sensor mounts to. Usually this is going to be the rear quarter panel behind the bumper. There's going to be a bracket, and it's either going to be spot welded or bolted to that rear corner of the vehicle. And then the sensor is going to bolt to it and be positioned in a way that it's pointed towards the blind spot of the vehicle. Now, when we go out to calibrate these vehicles, the ones that actually do need calibration, we're either going to be using the radar cone that's going to reflect the signal back to the radar, or potentially, depending on the application, it might be the Doppler setup, which actually it reflects the signal back, but it can actually take the radar signal that's coming out and it can change the frequency that it goes back to the sensor. And from what I can read on this, it's actually simulating a moving target with those Doppler setups. And there's Mazdas and there's Volkswagen Audis that require that setup. Most vehicles just use a cone, and that reflected signal back is enough to do the calibration, but then some of them take the Doppler. So if you're going to do these calibrations, of course, you have to be aware of what setup you're going to need. And again, some of them are just dynamic. Some of them you just go drive and it figures it out. Some of them you have to activate the function with a scan tool and drive it. But for the ones that, we're getting called in for, these are the ones where we're actually setting up a target at a specific point. Now, just a quick tip on this. If you want to find measurements for where to place the target, now, of course, you can look in service information and you'll find it there as well. But if you want something really quick that kind of speeds up the process, you can go onto the Autel website and just look up ADAS coverage, and you can enter your vehicle and it will give you the setup and configuration for whatever system you're trying to calibrate, including blind spot and radar. But what's nice is it just gives you the measurements right there, and it tells you the tool that you need. Is it a cone? Is it a Doppler? And in some cases, they summarize the placement of the target a lot simpler than what you might find in service information. And a specific example of this is Toyota vehicles. A lot of them, in order to place the radar in the correct position, they're having you measure an angle based off of the center line of the vehicle and then going out from there and placing the radar setup. Now, not that you can't do that. That's definitely possible. But I like just having a measurement out from the rear vehicle on the center line and then over. And if I have a 5-line laser or a couple 5-line lasers, which we do, and which I would recommend if you're doing any ADAS work, is get yourself a couple 5-line lasers that can both they'll send lines out in multiple directions. Okay, so you can send a line out that lines up with the center line of the vehicle, and then it also sends out a line perpendicular to that line, so you can go out and over the correct amount and place your target where it needs to. And then you have to set the height of the target and make sure that it's pointed correctly at the center of the radar. And a lot of times it'll give you the height measurement for that radar stand as well. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. The link is in the show notes. So all of that, you can find that on that Autel website. It's free. You don't have to log in, and it's quick and it's easy and it saves me time. So I thought I'd mention that tip on here if you're looking for quick setup tips. Again, you can look in service information and find it there too. It's just sometimes the setup in service information, especially for some of the earlier vehicles, it's just a bit antiquated in my opinion. Like, you can look at some of these and they're using strings to set stuff up, and using the lasers is by far the only way to go. It's so much faster, and I mean, quite honestly, probably more accurate too, as long as you're doing your setup correctly with the plumb bomb and the levels and all that stuff. The lasers are the way to go for sure. So we're gonna get our targets set up into place depending on the target that it needs and the position relative to the vehicle. Obviously finding the center line, making sure everything's level, measuring, getting it all set up. That's one piece of it. And when I first started doing this, was the only piece that I really thought about until we had some failures early on. We started doing these. We would either not be able to get it to pass calibration, like we'd set the stand up exactly where it told us to set it up, and it just wouldn't pass. Or in some cases, and this happened, it passes the static calibration in the shop, but then you go drive it, and after driving it for a period of time, when it's actually functioning in the real world, then it fails. It comes back with a code of like misalignment or angle off, or there's a variety of codes it can set, and then you have a warning light on and you have to fix it. So there's another piece to this, and you may or may not be aware of it. It's really probably just depending if you've done ADAS calibrations or not, because if you have, or especially if you live in a collision world, you know all about this, but the physical angle of the sensor matters. Now, when we're doing the calibration with the radar stand or the Doppler, it's going to calculate angles and it's going to make slight adjustments, but only within a certain threshold. And a lot of vehicles, this is within a couple degrees of where it needs to be, right? So it can only adjust its tolerances so far. And if it is physically misadjusted, it either, again, won't pass the calibration because the radar stand is not actually pointing at it, or I should say it is not pointing at the radar stand, so you can't pass it. Or sometimes I've had it where it passes and then fails out there, and this is because the actual angle of the component is off, and this is a physical misadjustment either from the bracket or the panel that the bracket is bolted to. Now this goes for front radars too. It's the same thing, and so when we get calls from shops saying, hey, we need you to come out and calibrate this radar, our guys are trained, and we ask for, hey, was there damage to this vehicle? Like, why are we calibrating this thing? Did you just replace it? Did you just have the bumper off? Was it in any type of collision? That's our real important question that we ask is, was there damage to this vehicle structurally? And if there was, we tell them, hey, we need access to this sensor, so that a lot of the times is bumper off, so that we can physically measure the angles of the sensor placement before we do the calibration. Because if we don't do that, either it won't pass or it'll pass in the bay and then fail out on the road. And we don't want to have to make a second trip and then charge you for that. Or we don't want to give you the idea that, hey, we did it correctly, and then it comes back with a light and your customer's upset. So we want to do everything correctly on that first trip. And so if there was any damage to the vehicle where a bracket might have been moved or a panel shifted, we're going to measure the physical angle of that component. And again, same thing for front radar. We see this a lot with front radars. They get dinged or smacked in the front and they'll replace the radar, but they will not actually get that bracket in the correct position. And honestly, it's not impossible, but it's tough to just eyeball that. It's very unlikely that you're going to get it within a couple degrees of where it needs to be just by eyeballing it. You're going to need some type of measuring tool to get it where it needs to be. And, of course, in some cases, you can just replace the bracket. And a lot of times that, may take care of it. But it is possible to have a structural damage in the component the bracket mounts to. And we've seen that, bumpers can get tweaked and panels can get tweaked. If you go way back, this isn't a radar, but it's similar. I had a Subaru where the roof line angle was different than what it needed to be. So crazy stuff can happen when these vehicles get into wrecks, and especially if you're dealing with, a salvage vehicle that's been totaled, because of an accident. I mean, there's a ton of reasons or a ton of things that can throw off the angles. So it's not always just the bracket, but either way, we want to verify the physical angle of these sensors before we do our calibration. Now, this is kind of getting into the meat of the episode and why I want to talk about this. There are two angles that you need to verify on these sensors before you do the actual calibration. All right. Now there's a horizontal and a vertical, right? So if you think a horizon is side to side, vertical is up and down. The vertical is easy. This is simple. And if you have an angle gauge, you could use a bubble angle gauge. I have a digital one. You just put the angle gauge up against it. And most of these sensors, and you might want to check service information for the spec because there is variation, but almost all of these sensors want to be at 90 degrees in reference to the ground. Okay. So if you're looking at it, should be straight up and down. Okay. And that's simple. You put your angle gauge up to it and you're looking, depending on which way you have it rotated, you either want it at 0 or you want it at 90. Again, there's variation in that. So check service information for this. And some manufacturers don't give you this straight out. Some do, but most of these are going to be 90. Now, if you're doing blind spot stuff, this is another thing, and there was damage on one corner of the vehicle, you can use the other side as a known good, but I would question what kind of accident was this in, because it's possible both sides could be messed up. If you're working with a front radar, I haven't seen one that isn't 90 degrees. I'm sure someone could probably give me an example of where that's not the case, but just about every front radar that I have calibrated that I can think of, it's going to be 90 degrees. Okay, now some of the front radars need a different tool in order to do this, right? The blind spots, you can just put your angle gauge up to it. My angle gauge is just like a rectangular device and it has a flat surface, and I push it up against the the front of the radar. You could also do the bracket if the radar's not on. I like to do it with the radar on, bolted up, so that I know the actual sensor is pointing the way that I think it is. But, there's an argument to say, and actually procedures that have you do the bracket rather than the sensor. I guess that's personal preference there. But on the front radar sensors, there are some that are dome shaped. Jeeps have this, Audi Volkswagens have this on some of them. And there's a bubble sensor that kind of has a cup on it that goes over these, and it will lock into place, and you use a bubble to calibrate these before you do the actual calibration. So those, you wouldn't be able to use the flat angle gauge, but again, we're kind of focusing on blind spot here. So vertical measurements, we've always been able to do very easy. Stick the angle gauge on there and, adjust it as needed, whether that be manipulating the bracket or using shims, whatever it needs to be, you can do that. Now, there's a second angle measurement that needs to be done, and this is for blind spot modules, but it can be for front radar. The nice part about the front radar is you don't have to look up a spec. The front radar should be perpendicular with the center line of the vehicle, right? So imagine the center line going down the middle of the vehicle. You put a line directly across that at 90 degrees. Your front radar should line up with that for its horizontal angle, okay? And that is a thing that can be off for sure, okay? But you don't have to find a spec for that. Now, for the rear blind spots, this is where it is tricky because they are at an angle, because they have to detect a vehicle or a moving target in the blind spot of the vehicle. And each vehicle is set up a little bit different. And so that angle relative to the center line of the vehicle is going to be different for each vehicle. And so I've seen this as small as 30 some degrees and as large as 70 some degrees. And I'm sure there's probably examples where it's even, more pronounced than that. But what I'm getting at is they're not all pointed the same way horizontally. And again, with the eyeball thing, could I get a front radar that's kind of close to perpendicular to the center line eyeballing? Yeah, I might still be off a little bit. Again, eyeballing this stuff's not the way to go. But I'm not going to be able to do that very well at a 45 degree angle or a 55 degree angle relative to the center line, okay? Again, I could probably get it straight up and down. That vertical, I could probably get pretty close, but that horizontal one is where it's tricky. So how do we measure this? Now, there are certain manufacturers that have tools for this, Hyundai Kia being one of them, and we actually have that tool. You take the kind of take the bracket apart a little bit, and there's another component in this tool that bolts up to the bracket of the blind spot, and it has a laser, and then you use that laser to compare the angle to the center line. And it's a nice tool. It's kind of expensive, and it only really works on Hyundai Kia stuff. You could probably get creative and use this on other manufacturers, but you'd have to modify some stuff. But of course, Hyundai Kia is not the only manufacturer where you need to measure this angle. Anything with a blind spot that's going to bolt up to the back of the vehicle, you are going to need to measure this angle if there was damage or suspected damage. And again, we want to do this so that we can confirm when we actually do the calibration itself with a radar cone that everything was in the correct position before we hit the button and said it's good. And if something needs to be adjusted, that's the point. Let's adjust it now while the bumper's off. And then we can go ahead with our calibration. So there's tools out there that can help you measure this angle. Autel has one. It's crazy expensive, in my opinion, for what it is. If you look this up, it is a mat with lines on it, and it is a metal stand, and it is an angle gauge. That's it. They want $2,100 for this thing. So I never bought one of those because I'm like, that's ridiculous. Now, granted, if you're doing these calibrations and measurements all day, yes, you can make your money back from that. But sometimes I look at something and I'm like, there's nothing that special about this thing. Like, I could make that and not pay $2,000 for it. If it's like a scan tool, I'm obviously not going to build a scan tool, right? So I'm going to buy it from the person who can make it. But in this case, I saw it. I'm like, well, I could probably make one of these things. So I got together with a few different people. I have a friend who works at a machine shop, and had us just make us a nice stand, has a nice metal base. And we did a couple different versions. We did a rectangular piece of metal that came out, and then we did a round piece of like a rod basically that stuck into this base. And then we went to a print shop and we had a mat made that just has lines that go across it with even divisions. And you could roll this mat out and line it up with a center line. You can go the other way, use a laser, line it up perpendicular to the center line and do some math either way. But basically you put this mat on the ground, you line it up so that it's either with or perpendicular to the center line. And then you have this stand that it's going to sit on the mat, and it is going to press up against the surface of the blind spot module. Okay. If you're not following me, look up the Autel one. You can see what the idea is. But what this is now is, well, actually there's a third part to this. One of our employees, it's a younger kid, we hired him last summer. He's been doing awesome. He's into 3D printing. So he 3D printed us a mount that can slide up and down on this metal rod, and it mounts up against the blind spot. Now, the one caveat here is some of the blind spots have a curved surface. Some of them are flat. We're still working on the one for the curved surface, but we're moving in the right direction there. We have the flat one down. Obviously, that's easier. But imagine a blind spot module. This will butt up against the flat surface of that blind spot module. And of course, you would want to get the vertical angle correct first. So get it at 90 degrees, and then you can do the horizontal one after. But we butt that up against that surface, and then it sits on this mat. Now, you could use the bottom of the stand to do the angle measurement in relative to the lines on the mat. But what my employee did, which is genius, is he put a laser on that shines down to the mat. So the laser is in line with the mount that goes up against the blind spot module. So effectively, the laser beam that comes down, it's just a line that shoots down on the ground, is at the same angle as the blind spot module relative to its position in the center line, right? So you're going to use the lines of the mat and the laser coming down and measure the angle. And then again, you can compare to the other side. If that side was not damaged or, didn't have any movement, you could use that as your known good, or you could refer to a specification if the service information gives it to you. Some of them do, some of them don't. A tip there, actually, you can look on the Autel site, and if you find that tool that I'm talking about, they do have a PDF you can download that gives you a bunch of specifications for different makes and manufacturers and what the angle is. It's not all of them, but it's quite a few, and we do have that document saved. It's just a PDF. So that's handy. So you wouldn't necessarily have to rely on the known good side. Because again, well, what if both sides got hit? Then obviously you can't do that. But you're going to do that and figure out where that angle is. Now, the laser thing's really cool, and I'm super pumped about it. I think it's awesome that we were able to make something like that. You wouldn't have to go that fancy though, right? You could do it with just, a piece of metal that's going to press up against that blind spot module and some way to measure the lines on the ground. Now, like if you look at the factory methods for doing this, Toyota has you do like a plumb bomb from the different bolts on the bracket and then using the vehicle center line. But if you read through that process, and I tried it once before I had all of this, it's an annoyingly long process to do. And I don't know, lots of room for error too, in my personal opinion. I like the lines and the lasers, and then we're just using a tool to measure that angle on the ground, and then we adjust it if needed, right? Now, again, this is why we need stuff like this, because this angle is tough to pick out, right? 5 degrees when it's at an angle is tough to call if you don't have these measuring tools in order to do them, right? But 5 degrees is way more than enough to either not be able to pass the calibration or have problems when it goes down the road. So I just wanted to put that out there to everybody, that this is something to consider if you're going to be doing calibrations, or maybe you're just trying to do a calibration for somebody and it's not passing. Like, you've done your measurements. I've got my target in the correct place. I know I do, but it is not passing the calibration for one reason or another. You might have to take the bumper off to look to see, is there any damage? Is there any, was there a tweak to a bracket or anything like that? You can have some other weird things too, right? You can have module issues. You can have metallic stickers on the inside of the bumper. Obviously, the bumper had been replaced in that case. There's other things that can prevent it, but that angle thing is like something I just want to eliminate as a possibility, okay? And you can use this same thing with a front radar. The front radars may be in a position where this stand idea wouldn't work exactly. But you could get creative and figure it out. Again, the front's easier because it should be pointed straight forward. And so it just needs to be perpendicular with the center line of the vehicle. So not as much thought goes into getting that angle figured out. Although, again, it might take a little bit of work to do that. And then the other thing is, hopefully, once we get everything dialed in, we kind of just have our first couple prototypes of this setup right now. But once we get everything dialed in and make sure that it works on, all makes and models, I might have it available in case anybody's interested. And this isn't like, hey, a sales pitch. I was just excited about this and I was sharing it with some people, and I already had some people ask me like, hey, can I get one of those? Again, because, and nothing against Autel. I mean, charge what you want to charge, but for what it is, I think $2,100 is a little ridiculous. So I would not be charging that much, but I don't know exactly what the price would be just yet. But if you're interested in something like that, shoot me a message, and we're probably, I don't know, a month or so away from like getting it to a point where it's sellable, and then we can figure something out if you're interested. But either way, you got a little bit more knowledge on the system now, in case you run into this. And it was definitely a thing that was a little bit of a hassle and a roadblock for us that I think we are pretty well set up to get past at this point. So that's all I got for you today. Thank you for listening. Hope you enjoyed that and learned something. Other than that, let's get out there, start fixing the world one car at a time.